Today we're going to learn on operations with radicals. So the radical is the symbol to denote a root. So you can see here, you're familiar with the square root symbol. So if you were to do square root of 4, that would be 2 because the square of 2 is equal to 4. So it's basically the opposite of squaring is square rooting. You also have seen cube rootings. You'd have the same symbol, but you have a small 3 out here. And the cube root of 8 is 2 because 2 times 2 times 2 is 8, or 2 to the power of 3 is 8. Similarly, the fourth root is written like this. You have the fourth root of 16 is 2 because 2 to the power of 4 is 16. So if you have a radical like this, which is the square root of 12, then the coefficient, which is the number out here, which is multiplied with the 12, not the number here, I meant like right here, which is multiplied with the 12, is 1. So the coefficient is 1 times root 12. You can also have mixed radicals where the coefficient is not 1, like you see here. This is 2 times square root of 3. So it's 2 times root 3, okay? So you have, and then you have like radicals. So these like radicals are radicals that have the same value under the radical symbol. So 2 times root 3 and negative 5 times root 3 are like because the number under the radical sign is both the same for both of these radicals. So they are like. So that brings us to some rules that we can follow in operations of radicals. So if you had to do the square root of a times the square root of b, it's the same as the square root of a times b. So you can bring a and b both under the square root sign, and this is possible when both a and b are greater than or equal to 0. If you have a mixed radical, that is c times square root of a plus times d times square root of b, then you can multiply the coefficients c and d, cd, times square root of a times b for a greater than or equal to 0 and b greater than or equal to 0. If you're dividing two radicals, square root of a divided by square root of b, then you can bring them both under this radical sign and say it's the same as the square root of a divided by b, or square root of a divided by square root of b, when a is greater than or equal to 0 and b is greater than 0. And if you're adding radicals, mixed radicals like this, c times square root of a plus d times square root of a, then you can bring the c and the d together, c plus d, you can add them together times the square root of a. So if you had 2 times root 7 plus 3 times root 7, then you can bring the 2 and 3 and add them together, so it's 5 times square root of 7. So we can also simplify a radical. So if you had to change an entire radical to a mixed radical, like here you have the square root of 12, you can rewrite the square root of 12 as the product of 4 times 3, okay, because 4 times 3 is 12, and then break it up into two products. So that's the same as square root of 4 times the square root of 3, and you can square root 4 because that's a perfect square and get 2 times root 3. So in effect, the number or the radical square root of 12 is the same as 2 root 3. They're the same value, okay, because it simplifies to that. So you can go back and forth. You can go from 2 root 3 and create an entire radical, or you can go backwards, which is from this simplified to create a mixed radical. Okay, so when you do the square root of 12 and you leave an answer with in the radical, that's the exact answer. If you took the calculator and did square root of 12 on your calculator, it will give you a number like this, and it's only an approximation. So the leaving an expression with its radical is its exact answer, whereas trying to find the actual value and round it is an approximate answer. So we're going to try out these examples where we are trying to simplify these radicals. Okay, so if you had square root of 25 times square root of 4, they're both perfect squares, so that's 5 times 2, which is 10. We can also get the same answer by bringing them both under this one radical, so it's the same as square root of 25 times 4, which is the square root of 100, which is equal to 10. So we're going to try that with all of these examples here. So first separately, so that's square root of 16 is 4, and square root of 9 is 3, and the answer is 4 times 3, which is 12. And you can also get the same answer if you did square root of 16 times square root of 9. It's the same as square root of 16 times 9, right? And then on your calculator, you do 16 times 9, you get square root of 144, which is 12. So you get the same answer. So you can see that they both are the same. Similarly here, if you did this, you can't really simplify them because they're not perfect squares, but if you'd like try to approximate them by taking the decimals, this would be 1.732 times 1.414. I'm just taking it to three decimal places, and I'd get 2.449048. And if I did it by putting them both under one radical sign, which is square root of 6, and took that number on my calculator, I would get 2.4494894743. So it's kind of close. You can see they're almost the same, but they both are approximate answers. Square root of 16 times square root of 3. 16 is a perfect square, so the square root of 16 is 4, and you can't really square root that, so you leave it as 4 root 3. And if you were to do it separate in a different way, where you bring them both under the same radical and create an entire radical, 16 times 3 is 48. And you can rewrite 48 as the product of, 4 times 4 times 3. 4 fours are 16 times 3 is 48. So then you can take the square root of 4 times 4, times root of 3. This is the square root of 16, which is 4 root 3. So it works out to the same answer. Okay. So we're going to try this. We're going to try these examples where we convert mixed radicals to their lowest terms by simplifying. And in example 3, we'll convert an entire radical into its lowest terms. Okay, so if you had this square root of 32, you can rewrite that as 4 times 8. 4 8s are 32. And you can write that as 4 times 2, because 8 is 4 times 2. And then you can break this up as the product of 4 times 4 under the radical times square root of 2, which is 4 root 2. And that is the mixed radical you can get from that radical. Okay. Here you have 3 times square root of 18. So 3 times, so let's rewrite 18 as 9 times 2. So that's 3 times square root of 9 times square root of 2. So it's 3 times root 2. So that's 9 root 2. And that's the mixed radical in its lowest terms. And we'll try this one here, square root of 15 times square root of 10. So let's rewrite 15 as the product of 3 times 5, and 10 as the product of 5 times 2. And I can bring them all under one radical, right? I can bring them all under like one radical and write this is the same as 3 times 5 times 5 times 2. So I have 5 times 5 under one radical and 3 times 2 under the other. So square root of 5 times 5 is the same as 5, right? Or it's a square root of 25, which is also 5. So in lowest terms, it's 5 root 6. And we're going to do now the other way around, which is we're going to go from a mixed radical to the entire radical. So let's rewrite, so we don't want any coefficients. See, all of these have coefficients outside. We don't want that. We want just an entire radical with the coefficient just being 1 outside. So we're going to rewrite the 5 as 5 times 5 under the radical times 7. So that this becomes square root of 175. So that's now an entire radical. So we did the opposite of what we did in this example here. Okay. Similarly here, you have negative 3 times square root of 6. So leave the negative there and bring the 3 into the brackets as the square root of 3 times 3, which is 3, times the square root of 6. So that's negative of 54. And here, bring the 3 under the radical, so it's 3 times 3 times 6. So it becomes square root of 54. Okay. Next, we're going to try some simplifications. Let's try to simplify these into their mixed radicals. So we're going to leave that as root 2 and rewrite 14 as root 7 times 2. And then bring them all under one radical, 2 times 7. So it's the same as 2 root 7. Part B, rewrite square root of 15 as 3 times 5 and square root of 21 as 3 times 7. Bring them all into one radical, so 3 times 5 times 7. So this 3 times 3 in the radical is just 3, and 5 times 7 is square root of 35. So there's the mixed radical. Here, we're just going to multiply the 2 times 7, which is 14, and then have 5 times 2 under the radical. So it's just going to be 14 root 10 as a mixed radical. 4 times root 6 multiplied with negative 3 times root 30. So you can multiply 4 times negative 3, which is negative 12, and multiply the root 6 with the root 30. Bring the root 6 into brackets, into the radical with the 30. And you can rewrite 30 as 6 times 5. And you have negative 12 times 6 times root of 5. So it's negative 72 times root of 5. Our next example, we are asked to simplify. So these are terms that you can add together. So I have here root of 2 minus 3 root 5 plus 7 root 5 minus 2 root 2. So I can add the ones that have the same radical. I'm going to write them together. So I have square root of 2 minus 2 root 2. They have the same radical. And then the middle terms have the same radical too. So minus 3 root 5 plus 7 root 5. And we can now bring this as square root of 2 times 1 minus 2, because that's the coefficient here, that's 1. And then plus square root of 5 times negative 3 plus 7. Okay, so we can do that, and you get negative root 2 plus 7 minus 4 is 7 minus 3 is 4 root 5. Okay, just going to draw a line here and do this one. I'm going to rewrite square root of 18 as root of 9 times 2 minus 2 root 12 minus 10 root 2. I don't have a lot of space here. I'm just going to rewrite that on a different page so I have some space. Open up a space here, and I'm going to just do that on the next page. So I have some space. So that's root of 9 times 2 minus 2 times root of 6 times 2 minus 10 root 2 plus root 3. So these ones I can actually take out the perfect square. Square root of 9 is 3, so it's 3 times root 2 minus 2 times 6 can be written as 2 times 3 times 2 minus 10 root 2 plus root 3. So that's 3 root 2, and here I can take out root of 2 times 2, which is 2, root 3, okay? Because that's 2 times 2 is 4, square root of 4 is 2, so I put that outside, and I have root 3, minus 10 root 2 plus root 3. So I can add the radicals that have this, that are like, so I can add this and this together, and I can add this and this together because they're like. All right, so I'm going to do that. I'm going to rewrite them together. 3 root 2 minus 10 root 2, and this one is negative 4 root 3 plus root 3. So that is root 2 brackets 3 minus 10 plus root 3 brackets negative 4 plus 1. Okay, so that's negative 7 root 2 minus 3 root 3. Okay. Next, we're going to try this one. 2 minus root 6 multiplied with 1 plus 2 root 6. So it's kind of, I'd have to like use FOIL. So multiply 2 times 1 and get 2. Then 2 times 2 root 6 will be plus 4 root 6, right? And then negative root 6 times 1 is negative root 6. And then negative root 6 times 2 root 6 is negative 2 times 6. Okay, so I get 2 plus 4 root 6 minus root 6 minus 12. So I can write 2 minus 12 together because they're like, and then plus root 6 brackets 4 minus 1. And I get negative 10 plus 3 root 6. This one is like expanding a binomial, right? It's like a minus b to the power of 2, right? So what's a minus b to the power of 2? It's a squared minus 2ab plus b squared, right? So I'm going to use that formula to expand this. So I'm going to do that right here. So that's equal to a squared, which is the square of the first term, minus 2 times a times b plus b squared. So it's 3 root 10 squared. So that would be 4 times 5 when I square this, because the square of 2 is 4, the square of root 5 is 5, minus 2 2s are 4, 4 3s are 12, times root 50, plus square root of 3 is 9, and square root of root 10 is 10. So I get 20 minus 12 times 5 times 5 times 5 times 10, so 5 times 5 times 2, right? 5 2s are 10, 10 5s are 50, plus 90. And I can add 20 and 90 together. 20 plus 90 minus 12 times, I can do square root of 5 times square root of root of, I can bring the 5 outside here because the square root of 25 times root 2. And I get 110 minus 60 root 2. And that's the simplified expansion of that. Now here we have a word problem where we're asked to find the perimeter of this shape, and we have the length of all the sides given as radicals. We're just going to add up all the lengths to get the perimeter, because the perimeter is the sum of all the sides. So perimeter is equal to root of 8 plus root of 18 plus root of 12 plus 2 times root 3. So we can rewrite 8 as the square root of 4 times 2, 18 as the square root of 9 times 2, 12 as the square root of 4 times 3, plus 2 root 3. And here, the perfect squares you can take out. So square root of 4 is 2, root 2, plus square root of 9 is 3, root 2, plus square root of 4 is 2, root 3, plus 2 root 3. So you can see that these are like terms and these are like terms, so they can be added. So that's square root of 2 times 2 plus 3 plus square root of 3 times 2 plus 2. So that's 5 root 2 plus 4 root 3. And that's the parameter. Okay, so now you can do the practice questions at the back of the book, the back of the lesson in the textbook.